You're listening to Word on the Reef, diving into marine science on the Great Barrier Reef and beyond, with Tanya Murphy and Brett Goodban. Good morning, everyone, and welcome back to Word on the Reef. I'm your host, diver and marine conservationist, Tanya Murphy. And with me, as always, is Cairns Aquarium's marine educator and fish whisperer, Brett Goodban.
Morning, Tanya. Morning, everyone. Welcome back.
Now, before we dive into today's interview, here is some positive marine news.
Oh, we like this.
A mother and daughter team have discovered the largest known coral documented on the Great Barrier Reef while scuba diving from their family boat. The gargantuan specimen of Pavona clavis coral, commonly called shoulder blade coral, stretches 111 metres in length and nearly 4,000 square metres in size.
Wow.
That's not a coral colony, that's a coral suburb.
It is.
It's got its own postcode.
It has.
At that size, it should be paying council rates.
Yep.
So Jan Pope and her daughter Sophie discovered the monster coral while taking part in the Great Reef Census, a project of citizens of the Great Barrier Reef, which we learned all about back in Season 2, Episode 15. You can listen back to that one to learn more about it at wordonthereef.com. Well done for that find, ladies.
Well done, ladies. Good job.
In other news, last weekend, local fishers found a massive ghost net about 16 kilometres north of Double Island in Palm Cove. They contacted marine debris cleanup organisation Tangaroa Blue, who have tagged the net with a tracker. It's estimated to hang 20 metres deep and weigh tonnes. So it's terrible. It's going to take a barge and crane to haul it out, but well done to those for finding it and reporting it. If you want to learn more about ghost nets and marine debris on our reef, we interviewed Heidi from Tangaroa Blue back in Season 2, Episode 10.
Yep.
So check it out at wordonthereef.com. But now, let's talk about what might be the most spectacular love story on Earth.
Oh, the world's biggest dating event.
We're talking about coral spawning again. It's the largest reproductive event on the planet. Brett, have you ever witnessed coral spawning?
Yes, I have. I've seen it a few times. It definitely changes you when you watch it. It's spectacular.
Yeah, I understand the first time you saw it was before you even knew what it was.
Yeah, this might come to a surprise to some people, but I was young once and I didn't really know a lot back then, and I was doing my dive master traineeship and I got in the water and the spawning was sort of happening around then, but I didn't really know much about it. And I saw this thing going off in the water and I stuck my head up to the crew and said, I'm not sure what's happening down there, but there's all this stuff coming out of the coral. And they went, oh, that's cute, Brett. That's called coral spawning. It's coral what? It was a long time ago.
So the marine biologist on the boat was like, come and sit down, Brett. It's time. I knew we would have to have this talk one day.
Yes, we need to talk about the coral and the bees, big fella.
So for those who aren't familiar out there, over a few nights after the full moon in late spring or early summer, so it's usually November or December, corals across the Great Barrier Reef synchronise their biological clocks and release billions of tiny pink bundles of eggs and sperm into the water all at once. It's basically the reef's biggest singles night, but without the awkward small talk and without the dinner and the movie.
There's a little bit of Barry White going on over there when you're down there, you can hear him.
Yep, and when the right moment arrives, boom, the ocean turns into a pink snow globe of spawn.
Yep.
Many of those little bundles will get eaten by predators, so it's a feast for our marine life, but some of them survive long enough to meet, fertilise and form baby coral larvae. Those coral babies then float around in ocean currents until they find the right surface to settle down on, like a nice rock, a recently dead coral or a patch of crusty coralline algae. Once settled, they are referred to as coral recruits or spat. In this phase, they start to build a skeleton and grow into a brand new coral colony. This mass spawning event is one of the key ways the reef regenerates itself. But with climate change driving more frequent marine heat waves and ocean acidification, even the reef's most romantic night of the year is under pressure. So today we're asking, can we give coral romance a helping hand? Can science play Cupid for the reef? To unpack these questions, joining us today is Dr. Cedric Robillot, Executive Director of the Reef Restoration and Adaptation Program. The RRAP was launched in 2020 with funding from the Australian Government and the Great Barrier Reef Foundation, with the goal of helping the reef survive climate change. It's a massive collaborative effort involving hundreds of scientists from multiple organisations, including the Australian Institute of Marine Science, CSIRO, and 4 major Queensland universities. It's one of the largest efforts on Earth ever launched to protect a natural ecosystem.
Wow.
So in my mind, I'm picturing the Avengers because they all have different powers and come from different backgrounds, but this crisis has brought them all together to save the world. So when spawning corals need help, all they have to do is shine the spat signal into the sky.
The fish Avengers.
And the crack squad will assemble.
Yes.
So one of these Avengers is Dr. Robbie Yeo, an adjunct professor at the University of Queensland School of Biological Sciences. He holds a PhD in environmental toxicology from the National Museum of Natural History in Paris and an engineering degree from the Paris School of Physics and Chemistry.
Wow.
Good morning, Dr. Robbie Yeo.
Good
Welcome
morning
to Word on the Reef.
Good morning, Tanya. Good morning, Brett.
Hey.
And amazing description of coral spawning.
Yeah, thank you.
That's probably the best I've heard so far. It's fantastic.
Wow, thank you. And how about my French? How did I go with pronouncing your name?
And again, well done.
Oh, good. 2 gold stars,
never easy,
Tanya.
And I think, again, that's a very good performance for a name that's really hard to...
Well, I had it in my notes to check it with you beforehand, and then I forgot. So how do you actually pronounce your surname?
Robbie Yeo, which is pretty much what you said. That was great.
Oh, thank you.
Look at you go. Just as well I didn't give it a crack.
Well, it's great to have you on the show.
Yeah, thank you.
Before we get into reef restoration, can you tell us a bit about yourself and your background and which member of the Avengers do you identify with the most?
Yeah, you caught me here, really. But I come from France. I came to Australia about close to 25 years ago. I did my studies in Paris. My family is from Brittany on the ocean there. A very different type of ocean. I moved into environmental toxicology a bit as a rebel in that school, where most people in that engineering school were going into heavy industries. And they were just starting to do environmental biotechnology. So I grabbed onto that, always been passionate about the environment. So yeah, that was fantastic. How I came to Australia is a bit of a funny story. I think I met an Aussie guy at a dinner at a conference in Paris, small table in a Parisian restaurant, and he asked me, if everything goes well, what do you want to do in the future? And I nerded him out with my dream of working with a special protein, which at the time was high affinity and soluble, which for some reason is really rare. And he told me, I know the world expert is in Townsville at the Institute of Marine Science, Lyndon Llewellyn. And put me in touch, and a year later I was moving my family to Townsville, working at the Institute of Marine Science there. And believe it or not, that protein was found in centipedes. And so I spent a good part of the year after that turning over sleepers in botanical gardens and under churches and finding these centipedes to work on these marine toxins.
Wait, so you're saying that there's something in centipedes which can help with... What does it help with?
With the corals. It's a protein that just binds really strongly to marine toxins. Shellfish and all sorts of things. Nobody knows quite why.
Yep.
Just turns out that Lyndon found it in his back garden as he was screening all sorts of organisms for this protein. And we used that to make medical devices and sensors for these toxins. And we put a company together, and that's how my journey started in Australia.
So if I get stung by a jellyfish or a stonefish...
We just go and find a centipede.
That substance from the centipede is going to help me survive. Is that what you're saying?
Sadly, not really, because they're probably more the octopus, the blue ring octopus type of toxins or what you find in crabs, but it's not an antidote. It's mostly a detection system.
Okay.
Well, that sounds like a whole episode in itself.
Wow.
And I understand that you grew up by the ocean in Brittany, but you also love sailing and snorkeling with your family as well. So you've got a bit of a connection with the reef in that way as well, right?
Yep.
Yes, it's a very different ocean where I come from, but my ex-wife was also from Tahiti, so we spent quite a bit of time in French Polynesia, which is really where I started diving among coral reefs. And as most people that dive for the first time in a coral reef, it's just a shock to the system. It's such a different world, and I fell in love with that, and moving to Townsville was probably part of that, getting closer to that Great Barrier Reef.
Okay, so let's talk about your work with the RAP. What is the Reef Restoration and Adaptation Program?
So it's a large science collaboration. In that sense, it's not uncommon, but it's very much focused on a mission of trying to find solutions and develop these solutions to assist the reef to resist the impact of climate change. We know that climate change is the largest threat to the reef and in fact increasing over time. And there's no silver bullet for that.
No.
We need to just deal with emissions, reduce emissions, stop emissions, and deal with climate change. That's the cause. But in the meantime, the reefs are already exposed to the level of increase in ocean temperature. We already see what it's already locked in, if you want. And so scientists got together after the bleaching events in 16 and 17 and decided that we needed to think about interventions. We couldn't just study and continue to study the impact of climate change. We also needed to see whether some solutions could be put together.
Yeah.
And so we screened a whole lot of solutions, and our role is really to develop them and make them available to reef managers.
Wow. Okay.
And so it started in 2020, so it's a relatively new thing. And one of the things, I guess you said that you've screened a whole bunch of different suggested solutions, and one of the ones which has obviously made the cut, because it's been started to be rolled out, is the assisted reproduction. Can you tell us what that involves?
Yes, so there are different ways we can assist the reef in this period and in the future. One of those is essentially to assist both the natural recovery after events to try and sustain that biodiversity, which will be core to any future recovery in the future, but also in the long term. But also, we want to assist with adaptation. If you look at coral reefs around the world, they can live in under higher temperatures.
That's
if you go
right.
to the Red Sea or the north of the GBR already, you see some very elevated temperatures. And so they can adapt. They're very good at adapting naturally. But that adaptation, the pace of that natural adaptation is clearly not enough to deal with how fast temperatures are ramping up. And that leads us to all these marine heat waves you mentioned in your introduction.
So what would the process be? Would it be grabbing those corals that have a higher tolerance and bringing them back to the lab and sitting them in there with ours and get them to chat to each other and hopefully they change their ways? How does that work?
That's right. So we do a number of things. So the way we look at this is to think about how we can, first of all, reintroduce or reseed corals in the system in very large numbers. Because if you want to have an impact, whether it's just repairing a local area or introducing corals that have an improved trait so that they mix in the local population, all of that requires very large numbers of corals. So we need to think about how to do that differently, because at the moment the world is not there in terms of numbers and cost. But we also need, as you just mentioned, to do that in a way that allows us to start then improving heat tolerance. And you can do that by finding corals, as you said, that are better or already adapted and get them to reproduce in large numbers and give back these traits to the system by reintroducing the younger corals with these traits.
Yes, that's right.
Or
so
you can do
them.
other things. That's right. Or you can also move corals from different places and move larvae or treat them with different symbionts or different stressors to try and promote that resistance. So there are different ways to make corals more thermally tolerant. So it's a combination of how you make them more tolerant with tackling the scale and the numbers we need to make a difference.
Because it's quite a difference, isn't it, that temperature tolerance ceiling from our corals on, let's say, the middle section of our Great Barrier Reef to those, say, in Mexico or other places like that. They have quite a higher tolerance, don't they?
Well, just from the south to the north of the reef is a couple of degrees.
Yeah, it's a big difference,
isn't it?
Yeah.
That's right. There's a big difference. And what's interesting is that people say, oh, well, corals in the Red Sea, for example, in Saudi Arabia or, in these places, they can sustain much higher temperatures. Well, guess what? 2 years ago, they bleached. Because it's not so much the temperature in absolute terms, it's how different it is from their long-term average and what they used to.
Yeah, right.
And so it's not as simple as moving corals from one place to another or assuming that, they have inherent properties. We also need to think very hard about how that integrates with the wild population and how you can assist adaptation without disrupting the ecosystem.
Well, I think there's going to be issues with moving corals from one country to another because you're introducing potential feral species. We've seen what happened with the cane toads in Queensland, for example. So I can only imagine that you're more looking at moving Australian species. Is that right, Dr. Robbio?
Absolutely. We are not talking at all about moving from other countries for sure. But also even simply moving from one sea country to another has a lot of significance for our traditional owners. So there are many reasons why we don't willy-nilly just move corals around. There's also the fact that physiologically, a coral that is used to operate in a temperature that is higher on average doesn't really love being put in a cold place. They actually grow
kind of like Brett.
A bit like me in Tasmania. That's not happening.
That's exactly right. So they might select themselves out over time. So it's a fine approach, that's why research is absolutely critical. It's not just an engineering problem. It is an engineering problem to an extent, but it's not just that. A lot of research needs to be done.
Okay, so we understand the principle. How does it look in action so people can picture how do you actually capture these spawn out at the reef?
Yeah, so there are really two different variants of this intervention. One is the one where we select the broodstock, so we select corals in the wild and we bring them back into an aquarium, at the moment the National Sea Simulator at Ames, and we breed them there and we settle the larvae on special devices which we can then reintroduce in the field in large numbers. So think about that as one path, and it's probably the more industrial path to make these corals.
And what are the devices? Are they just little pieces of ceramic tiles, or?
Yeah, so it's a bit hard to explain on radio, but essentially think of large plates of concrete on which we settle all these larvae, these baby corals. Then it's almost like chocolate tabs. Then we break these tiles into little square, 1 centimeter by 1 centimeter, roughly. And these little squares will have maybe 5, 6 corals, 10 corals on them. And we place these little tabs, 3 of them, in a device which is star-shaped, and it's essentially a heavy ceramic. It's inert, so it doesn't damage the environment, but it's designed in a way that we can, throw it off the boat, and it just drops. It's very heavy, and it drops straight into the reef, and it embeds itself into the reef matrix.
Wow.
Then the corals, which are at this stage still very young, like 30 days old, start growing, and one of these corals will survive out of all the ones that were in these little devices. And this coral is the one that will just essentially establish itself as a colony in that reef.
Wow.
Wow, that's so
cool.
cool.
The device itself disappears. It gets embedded in the matrix.
Yeah.
So you're basically zooming around, throwing ninja stars off the back of boats, which have corals growing on them. How big of an area can you cover with this? Do you have to, obviously the Great Barrier Reef is more than 2,400 kilometres long. In area, it's bigger than New Zealand, I think. It's almost as big as Germany.
Obviously, the scale is crazy, right? So on one hand, so that's one method. The other one is where we collect, as Brett described, we collect the spawn during spawning night. So we collect all of these leftover gametes, these egg bundles, and we promote fertilization, and we rear the larvae in special pools. It's just essentially a ring, a pool with a plankton net inside to shelter the larvae from the environment. They grow in there for a week or so, and when they're ready to settle, we do the same thing. We either release those directly on the reef, or we settle the larvae on devices, and then it's the same process. We can control where we put the devices. So,
yeah, I think I've seen those.
Yeah, well, I've seen the pictures as well. It's like a big plastic baby pool that floats in the ocean.
Yeah, with all the little babies in it.
But the bottom of it is net-like so that plankton can still get in for the corals inside to access the plankton?
Yeah, that's right. You still want the larvae to have what they need to get ready to settle and to grow, but you don't want to expose them to predation, because when the spawning happens, it's a party for the fish there.
Oh, yeah, it's on. It's a buffet.
Yeah, it's a buffet. So
a giant seafood buffet.
We're not really trying to just make the corals more vulnerable. We're trying to help them out.
Yeah.
But the bottom line is, at the end of the day, you end up with corals that have settled on a device that we can then put in the water. So in terms of addressing the question of scale, people often get confused when they say, oh, you're trying to rebuild the Great Barrier Reef, billions of corals. No one ever could dream of rebuilding.
No, that's right. No, that would be...
it would be crazy.
Yeah, it'd be like replanting Japan if it wiped out, because it's bigger than Japan, and going around seed by seed and just trying to regrow the entire country.
Exactly, and it makes no real sense if you don't deal with the cause of the problem. So if you look at Florida, it's very different, because in Florida, they've lost most of their reef.
Yeah,
down
it's awful.
to 20 individual colonies in some places. So, of course, they need to rebuild. On the Great Barrier Reef, what we want to do is sustain. So the way we do that is by really targeting species and reefs where the corals we introduce will best mix with the local population and slowly, slightly nudge adaptation, accelerate adaptation so that they're better prepared and more resistant to the marine heat waves as they come. And over time, what it does sustain that natural recovery capacity of the system. But there's nothing that replaces that. And the reason we use these two different types of methods is the one in the aquarium is more controlled. So we have more understanding of what we're doing. It's a more targeted approach. The one in the wild, we rely on the natural biodiversity of the system. So we have many, many species and many different corals. So the genetic diversity there is enormous. So it's a bit of a mix of these two interventions to try and achieve a similar outcome, which is to sustain the resilience of the system and prepare them for what's coming.
So I want the listeners to imagine that they are on this journey. So we're going out on a research vessel with dozens of scientists, traditional owners from that sea country, and we're waiting for the coral to start spawning, and as soon as someone smells it on the wind, we know that it's started, and then we're jumping in our Spatmobile.
Spatmobile, where do you get this stuff from?
If you guys don't call it the Spatmobile, I'll be very upset. So we're talking a smaller tender boat. You're going out with those nets to catch the spawn as it comes out. Is this kind of how a typical night in the life of of this project looks?
That's not too far off, and that's another thing that Brett didn't mention with spawning is that it stinks.
I actually was going to mention that you don't use your best dive gear on spawning night. I learned that many, many times.
Just set fire to your wetsuit afterwards. Is it like that?
It never leaves you.
I can tell you, just in November, December, I was in the field, and there's nothing more interesting than seeing this very expert, these amazing expert scientists just smelling in the wind, going, "Oh, I think this is spawning." It's just really,
there's no question about what you're smelling.
New innovation, trialing sniffer dogs to help you find the spawn.
You know what? I'm actually we're half joking here because we are actually working on better ways to detect the coral leaks, so we can optimize that process as well.
We could try and sniffer seagulls.
It's romantic, but I don't think that's very much a scalable approach.
I think my dog will be able to smell it from 20 miles away.
Absolutely. And I think, replicating this kind of, sensitive systems for detection of all sorts of smells or odors is something we do in other fields, right? So we always try to take things that have been developed in other areas, which is kind of my specialty, and try to move them across to our field. So that's one example. But the way you described it is true. The only thing I would say is we are very consciously trying to move away from just running this as a research program. So when you said a research vessels gets there, actually, in the pilot deployments we've started in the last summer season, we're trying to rely on local infrastructure as much as possible. So we will work with tourism operators that have vessels with the Marine Park Authority, with Queensland government, to use the local vessels and infrastructure and skills and teach them how to do this. And obviously, traditional owners are a key part of that, but also citizen scientists of the kind that discovered that amazing colony, as well as, industry operators. And we bring all these people together, we run all these training sessions, and then, it's like commando. We just get ready. For the next few nights, we're going to go out there and we're going to watch. It's often made a bit more difficult by having journalists that love to get out there and be involved as well. But it's all very community-driven, and I think that's something that we really like in some of these methods is that we can see a pathway to handing them over to the people that actually live and breathe on these reefs, whether in Australia or in, for example, Pacific Islands, where we're already doing some work now to take some of these technologies of sexual reproduction to some of these communities. And it needs to be designed and delivered in a way that is, culturally sensitive, but also that they can grab, that they can use, and they can make their own as well.
That's such a good way of doing it, isn't it? Including traditional owners, local scientists, local people. Mm-hmm. That's how you continue on your work, isn't it? That's how things progress.
People have a huge appetite for that. I think it's genuine. People really care for their reefs, and they want to be involved. And so there's always that tension between continuing to do the hard science and continuing to invest in what needs to be done, and there's a lot we still don't know.
Yeah.
But making the effort to taking it out of the lab into the hands of the people, and guess what? When you do that, you actually get some information both ways.
That's right.
Some of the industry operators know the reef better than anyone else, and same for traditional owners. So it's actually a two-way learning. It's not just a one-way process.
Yeah.
So just like the Avengers, like the Incredible Hulk, he's a scientist, so he spends some time being a nerd in the lab, and then some other time being a Hulk and doing the action scenes. I'm not going to stop with the Avengers references.
I haven't answered your question about which Avenger I am.
Yes.
Which is the one that stays in the office behind everybody else, trying to raise money and coordinate the program.
Oh, you'd be Iron Man then, the scientist in the lab.
Oh, well, maybe. Well, that would be good. But I think he's probably more involved in the action than I am, unfortunately.
Who's the guy behind the scenes of Batman?
Oh, yeah. I don't know.
That's you.
Yeah.
Our guest today is Dr. Cedric Robillot, Executive Director of the Reef Restoration and Adaptation Program. They've got a assisted reproduction project to assist the corals on the Great Barrier Reef in dealing with the threats that they're facing from climate change, which basically, as we've been discussing so far, is that they collect coral spawn both out on the reef and also spawning them in aquariums. They collect all the coral spawn, settle it on small pieces of concrete, and then distribute hundreds or thousands of these off the back of boats to grow new baby corals. And we also talked about how the tourism industry has been really instrumental in this by using their vessels to take the researchers out and distribute these corals and really help with protecting the reef. And so Dr. Robillot, this is quite a new initiative. Which was the first year? Was it last year or the year before when you distributed the first of these coral recruits?
So we have been doing this work for experimental testing and learning for a number of years now, but on a relatively small scale, but also in a very, with a research focus, trying to vary a whole lot of things to understand what makes a difference. But last year is the first year that we started what we call the Pilot Deployments Program. It's an initiative that has been funded, again, by the Australian government, in this case, to essentially demonstrate how we would scale up this technology. And so the purpose of this is not to, if you want, help the reef right now. It's obviously helping the reef by doing it. But the goal is really to understand how you can take it out of the lab, put it in the hand of the people we'll think in the future will be delivering these interventions day in, day out, and show how it works. Mm-hmm. Can you design the systems? Can you replicate those? Can you scale that up? Can you hand over the technologies and the procedures to other operators to see how they deliver this, and to have a look at how that responds in the environment over time.
Okay, and so we already discussed that the reef is nearly as big as Germany, so we can't zoom around throwing baby corals off the back of boats on all of it.
No.
But whereabouts on the reef did you deploy this project last year, and where will you be aiming to target this project?
Yep, so we operate at the moment in the Cairns Port Douglas area with a clear focus, obviously, on the tourism industry, but also on local industries and traditional owners. So we have about 3 or 4 reef locations in Agincourt system, Arlington, Alford, Moore. So there are a few reefs we're tackling here. And then the other site is in the south, around Wopabara, the Keppel Islands, where we already did some work in the past. And here in that location, we actually work with traditional owners mostly and some in tourism operators to deliver the work. So there's slightly different focus. One is an inshore reef in the Keppels, not the case in Cairns Port Douglas. But the idea is to learn as much as possible across both sites. And to give you an idea of numbers, just so we understand the scale, which is often a question that is asked, for us, scaling up is to demonstrate that you can do it at the scale of a reef cluster in a way that is cost-effective enough that you can start thinking of replicating. So imagine if you are able to do this in the kettle, and you can demonstrate how you can use local capability and capacity to do it, and you can deliver enough corals to make a difference for that location, then the process of scaling up is essentially to continue doing that work with other groups along the coast. And if we can demonstrate that it's cost effective within that area, then it's a matter of replicating. And that's how we define our numbers. You won't be able to tackle every reef. We know that in the future we'll need to focus on the reefs that we think are most significant, the same way that the Reef Authority focuses the cost control program, the crown-of-thorns starfish control program, on the reefs that are most important to the system.
Okay, and so part of the plan for the future is also something out of a science fiction movie. I understand there's a plan to use robots to go and plant all of these baby corals out on the reef?
Yeah, so I mean, the goal was always to remove the need for divers. So if you look at the global, there are many people around the world trying to do restoration, and the technologies generally rely on heavy labor underwater, planting, attaching, which is okay.
It's logistically very expensive and difficult, isn't it?
Yeah,
it's expensive
huge
to scale up, but it's great from a community engagement point of view, and it's also sometimes the only way you can do it, but it's not really scalable for a system like the GBR. So removing divers was a key feature for us, and that's why you see us using a system that we can deploy from the surface. When you can deploy from the surface, suddenly that opens the door to automation and automated systems. So we already have systems right now that look down from the surface on the reef, identify the spots where it's okay to drop a coral, and release it.
Wow.
And so in the future, you might think that you come with a fleet of those on the back of the boat. They have the racks to put the devices with the corals, and you just let them go. And of course, AI is involved in all this to recognize what's at the bottom, but also potentially to coordinate that effort better. And again, reduce cost, make it more manageable. So we're opening plenty of options. The question is more about, how you progress this in a rapid but measured way.
So how many corals did you deploy so far? And maybe it's too soon to know, but do you know how high is the survival rate?
Yeah, so look, so at the moment, so just to give you an idea of scale, the world combined, I couldn't say the number because we don't track that live, but the number of corals planted or seeded around the world might be between 100,000 to 200,000 per year or something like that.
Wow.
Maybe a bit more.
Yeah.
What we need on the Great Barrier Reef in our models is to have a minimum of 10 to 50 million per year.
Wow. 10 to 50 million per year.
So you're talking of a completely different scale.
Whoa.
Cost is so important for us.
Yeah.
And the technology is important, but also obviously the people aspect of it. You need to develop these armies of people that can do these things themselves. But so the numbers, what we've deployed this year is quite modest. We've deployed 40,000 devices, even though we collected, 15 million of eggs and 19 in the aquaculture, 19 million of these larvae. That's only leading us to 40,000 devices that we were able to deploy. For us, it's great. We need to go slowly, make sure we involve everybody in doing this. Our target is to get in the 100 to 200,000 per year by the end of this program, which is limited to, again, these two locations. But that's giving us all the information we need to know what's feasible, what's working, what's not working, and to understand cost. Now, right now, the cost is really high because we're building capacity, we're building capability. But what we're learning is really giving us a good indication as to how we would streamline this in the future that is, more routine. And to try and understand the cost structure and bring it down. And that includes how we produce the calls, but also how we deploy those. And so only 40,000. In terms of survival, yes, you're right, it's too early to know. And I always say to my team, look, it's, there's a good chance that they won't survive because we're learning how to do this in a more streamlined way. It's less control than in the research environment. But the reality is that over time, we should start getting some statistics that will give us a good understanding of the feasibility. In the past, we've seen 50 to 80% survival for some of these techniques to 1 year old, which is great. But, I can't exclude that we might end up with 10, 20% this year. And I say to my team, that's okay. we need to know how we get to this higher level. But this is called a pilot for a reason. That it's testing a whole lot of things in those systems that we need to understand before we think about adjusting and improving the system. So I think we're learning, but yeah, the goal is definitely to head towards these large numbers.
What are the limitations of this project in terms of saving the Great Barrier Reef, and what more needs to be done to save the reef and its wildlife for future generations?
So look, it's a simple question. Look, the reality is that this work will not save the reef unless we deal with the cause. So we've been consistent, and you will not find a single person in our program that will not stand up and say, the only way to save the reef is to curb carbon and greenhouse gas emissions.
Yes, that's right.
This is the only way, right? There's no other option, but it's not okay to just let the system collapse while we take care of the emissions, which is a global issue. So our message is that you need to do both. So for us, for this project to succeed, we need to sustain the biodiversity as much as we can and the recovery capacity of the system as much as we can over the next few decades. Our models show, you look at the IPCC report and others, that if we can control emissions, there will be a point where we will peak and the pressure will reduce. If there's no reef left at that point, it's irrelevant. So we want to make sure that we sustain the system, make it more resistant, and help it adapt while we deal with emissions. But if we do not control emissions harder than we are today, it's looking pretty grim, yes.
This project it seems like it's going to change the Great Barrier Reef a lot. I mean, there's going to be these little tiles being thrown in all over what used to regenerate itself naturally. Are there any risks associated with intervening in the reef's natural processes in this way? Are we playing God, so to speak?
Yeah, I think that's a very important question, especially with the history of Australia and how we've managed some of these environmental tests. I think in the case of, in what we're doing at the moment, we're working really, really closely with the Reef Authority, and we have an independent expert group that reviews the risk. They're not involved in the program, they're international, and they're really looking at all the different ways in which this could go wrong. The reality is what we do at the moment is still pretty small in terms of the impact. We're not introducing weird new species. We're not introducing species from somewhere else.
No Franken corals.
So yeah, exactly. We're not bringing super corals or anything like that. We're just working with the natural capacity of the system. So that reduces the risk significantly. So we work with the local population. We reproduce them. We bring them back. So we're not doing anything that is dramatic in that sense. Is there a risk in terms of the devices and how we do that? No. They're inert, and frankly, we have trouble figuring out where they are after a little while because the system itself just is used to absorbing all of these things. So you're not going to end up in the field of techno-looking reefs. You won't see the difference. A coral is a coral. What's more challenging for us is that it's impossible to recreate the biodiversity of the reef. We can work with, a couple of dozen species, which we will, but that's not going to offset the loss of potentially the rest of the 400 and also species. So it's about maintaining the system enough that the natural recovery continues, that they continue to spawn, that they continue to reproduce, to sustain the baseline biodiversity. But if you're asking me, will the reefs be different? Independently and irrespective of our program, the reef is likely to be different. It will change over time, and we already see it. Yeah,
we're seeing biodiversity loss, obviously, because some species can withstand extreme weather and heat waves better than others, and some are able to work better with this tile settlement system. So some species are going to win from this redistribution of their species, and others might not be so well adapted to it. And also with the selective breeding for heat tolerance, whenever you select for that trait, you might be losing other traits, right?
That's right, and that depends on how you do it. So the work we've done, for example, on the symbiont, we've seen that we haven't identified any trade-off yet because it's a natural thing that corals do. They pick the symbiont that they prefer. So if you give them a symbiont that's more suited for elevated temperature, that doesn't mean the coral itself will not grow as fast and not be as happy as it used to be. It's different if you select a coral and take it to an environment that's different. Absolutely, there will be trade-offs. But, it's a bit like a forest that's been burnt. You see weeds coming back really quickly. Some of the corals we see that are fast-growing, weedy types of corals, these cycles of rapid bleaching happening more often will promote this type of corals that grow very fast in recovery, but also die really fast during bleaching. And so you start to see the change in the makeup of the ecosystem that's completely irrespective of us. Our impact in terms of our decisions and how that impact the makeup of the ecosystem going forward. This is exactly why we work in that system, with the Reef Authority, with other scientists, with communities, because who is to decide what values you're trying to sustain? And at the moment, we work within the World Heritage Area framework where there's a pretty clear set of values we try to sustain, and that will guide. It's not up for us to decide in the future which reef might get which species, but I would expect that there will be a complex and nuanced decision framework there to go, okay, well, this type of reef, if we want to sustain the recovery and maintain its function, this is the makeup we're trying to sustain. And we're not there yet, right? Because first, we don't need to be there yet, but we're also learning a lot about how the system responds to the current growing threat.
So much to unpack there, but we only have 9 minutes left. So one particularly burning question. Australia remains one of the highest per capita carbon emitters in the world and is still a major exporter of coal and gas. Since RRAP was launched in 2020, the federal government has approved several new fossil fuel projects, including major gas and coal expansions. Is there a risk that by focusing on reef restoration projects like this, there's a risk of distracting us away from the urgency of cutting emissions and transitioning away from fossil fuels?
I would say there is a risk, obviously, if that was done with that intent. I think you'll find that we'll move well past that. So when I started with this program, clearly there was a concern that Australia was not doing enough on climate change itself. And that, doing this might make you feel, the reef is okay, we don't have to worry about this. We've been very clear within our program, in our communication everywhere, that climate change is the number one threat. We are not a solution and there's no silver bullet. So the only way to deal with this is to deal with climate change. And because we've been advocating, repeating this, every time we get a chance, we do that in our publications, in our communication. I don't think we can be accused of being a distraction. The reality, though, is that was kind of the debate a few years ago. Now people understand that because the effects of climate change are already happening, you need to help them sustain that biodiversity. And that's not a distraction, actually. It's the core of how you manage that transition to a future where we deal with both with climate change and the risk of that, as well as how to sustain biodiversity. The same way you help koalas right now. Even though they're suffering from urban encroachment, you're not going to let the poor buggers die. You're trying to manage what you can with what you've got while you try and put pressure on the coast. For me, that's two sides of the same coin.
I mean, the time to cut emissions was 100 years ago or 50 years ago or even 10 years ago, but world leaders have left it to the stage where we also need emergency first aid as well.
Well, that's a saying that we heard a while ago, wasn't it? That all the amazing people like yourselves, Doc, and everybody that's working behind the scenes to save the reef, that's first aid, but lands the hospital. If the hospital doesn't work with us, then it's just going to be too hard, right?
Look, absolutely. And look, on the Great Barrier Reef, we are lucky enough that we're not Florida. We haven't lost everything. We haven't suffered from major diseases on the Great Barrier Reef. That could happen, but equally, we still have a few decades if we're lucky enough to try and make a difference. And we can't squander that. And the world is looking at us going, you still have a system that is connected, that has some resilience built in due to the fact that it's so big and has so many different conditions. You are a rich country. You have the scientific capacity and capability to actually try and make a difference. The message we get from other groups is, if you can't do it, who can? And so we are pushing really, really hard to continue that work and not just being hopeless and just sit When you look back 5 or 10 years ago, we've made so much progress already, and that's what I tell my people. In the now, you might feel it's hopeless. But if you look back to how much we've achieved by just getting on with it, it's actually quite remarkable.
And that's the message that I give my customers in my reef shows at work every day. You know, even if we look back 20 years ago, the difference, even in the way that people think and all the actions that are happening now, is massive.
Yeah. Just going to jump in because we don't have that much time left, because I think we could talk for a long time about the
probably weeks.
Philosophical questions, which I asked, obviously, and it is a massive one to unpack. I think, I agree. All the scientists working on reef restoration are very knowledgeable about the seriousness of carbon emissions and so on. I think some bad actors, like climate deniers in other sections of society, sometimes use this information, like, we can just restore the corals so everything's going to be fine. I think they sometimes misuse that information, but I think that's being generated from people who don't know what they're talking about.
It's like Kevin at the pub.
Kevin at the pub.
We love Kevin at the pub.
We know him well. He's been on our Instagram lately, posting some of his wisdom.
We have got a Kevin from the pub, actually.
All right.
Corporations associated with the fossil fuel industry have donated money to a range of reef restoration projects around the world and Australia. What role do you think corporates should play in supporting reef restoration work on our reef, and how can we avoid greenwashing?
Yeah, look, my view has always been that every corporate should feel the responsibility to invest in the environment, no matter what they do, no matter where they come from. The challenge with this, obviously, is there's always an ethical choice as to the policies that the companies apply. So, for example, a company that, do slavery or children exploitation or denies climate change, we would never accept any funding from this company. So there's obviously a bar that you need to pass. But I think generally they have a role to play, and they should be encouraged to do that. The way you manage the risk with that is the claims. What claims do they make? They have absolutely no right to make a claim that they're saving the reef. Absolutely not. Can they claim that they invest a portion of their profits into environmental activities? Yeah, I don't have a problem with that. It's the claim space. The other space that is very dangerous and needs to be watched for is when that investment comes with controls on what you can do, what you can say, and that's absolutely no-go. I've never experienced it. I'm sure maybe some people have experienced it around the world, but all the people I've worked with, for example, BHP has been involved in the rain restoration project, which has protected thousands of turtles. They've been involved in Reef Island. They've been involved in e-reefs. They've done a number of things through their foundation. I've never seen an instance where we were controlled in terms of what could be said, what could be done, how we could communicate. And that, for me, for us, that's the area we don't let them go into, because otherwise, yes, you're right, it's greenwashing.
Yeah.
But I understand completely the question. It's difficult, but we need to understand that they all have a role to play. So do we. We still drive cars, we still do a whole lot of things that are polluting, but we do need everyone to invest in this. In fact, I would argue they should invest much more, not just, all sorts of corporates should invest much more in this.
Absolutely.
As to the reasons, Tanya, why they do that, I can hear and I can understand that it's okay to be cynical about the reason, right? I am not naive, but I won't pretend either that I understand what's behind any company making a decision to invest in X, Y, or Z. But I'm not naive. They might have reasons that I wouldn't like. What I'm more interested in is that we get funding to do the work that's critical, that they have a corporate responsibility to invest in supporting society and the environment, and that we do that in a way that's unencumbered and without claiming that we've saved the world or saved the reef, which would be outrageous, obviously.
Yeah.
In the 1990s, renowned reef scientist Ove Hugh Goldberg predicted that at current rates of carbon pollution, the Great Barrier Reef could be largely gone by 2050. At the time, he faced heavy criticism, but in many ways, the science is tracking close to his predictions. 2050 is now just 25 years away. As a parent, what kind of reef do you think today's children are likely to inherit?
Yeah, look, I find it really, really difficult to first of all, Ove is a colleague and friend, and we've had many, many debates.
Yeah.
He was right in pointing that out. And recently we've had good conversations about, he's still very pessimistic, and so he's been focusing in the past on the messaging around saving some of the critical reefs around the world, because we can't save everything. And him and I have had good conversations about the fact that, yes, we can focus our technologies. Even to save these reefs will require new technologies like ours. But if we can do that well, we could expand that to other reefs and not just the few critical ones. We can do more than that. So we have that little bit of tension over and I, but I think we came to that same point that we need to focus our resources and support the systems we think are critical. What does that mean for future reefs? It really depends how you engage with it. You go to Florida where there's almost nothing left and they still have tourism. They still have people diving. They still say they have a reef. And
people just lower their bar for what they expect.
It's the myth of the frog in boiling water. We don't realize it. And I think people that dive on the reef often don't realize how the reef was 30 years ago. Mm-hmm. And I think that's the problem that I see, that my children will never experience the diversity. But will that be a shock? No, because they won't have experienced it.
They've got nothing to compare it to.
We have.
Yeah.
And that's depressing.
It is.
Yeah.
Very depressing. So maintaining enough beauty and resilience so that the species that make this reef amazing can still be there is very important.
Yep, I've definitely seen that shifting baseline or the lowering of the expectations of what makes people happy to see it on the reef. Even when I was in Thailand, I dived in a reef I dived there when I was a child, and it was totally healthy, very high coral cover. And then I went back as an adult and it was completely decimated due to local and global impacts. And there was pretty much all I saw was a bunch of sand and a lot of dead rocks and corals and some parrotfish swimming around, scraping the algae off the rocks. And all the other British tourists that were on the tour got out of the water. They were like, that was amazing.
Oh, I know.
That was the best thing I've ever done. I saw so many colourful parrotfish, and they wouldn't have a clue because they haven't snorkeled anywhere else before. So,
and what you describe is exactly what we've experienced in some of the Polynesian islands in French Polynesia, where the coral diversity is in the dump, but the type of fish that have colonized that area are some of the fish that people love seeing. The bigger fish, and they're more active and they're more pelagic, and so people go there and say, oh, it's so much more beautiful than even 5 years ago. And we as coral experts are just crying inside. Going, this is not what it should be. And that's where I mentioned to you before, working with people to understand what values we're trying to protect. Because if it's a tourism park, or if we're just trying to have a live aquarium for hotels, that is not what we're trying to do. What we're trying to do is sustain the biodiversity and functional capacity of that system for a whole lot of trophic systems, as well as all the other services that the reefs provide, and just purely because that's the right thing to do.
Yeah. Well, I actually had the same incident happen to me the other day. I had a customer come up to me and they went, oh, we went diving. I said, oh, that's really cool. Where did you go? And they mentioned a site that I've done literally thousands of dives on.
Yes.
And I said, oh, how was it? And they went, oh, it was magnificent. And I just started sprouting off all the stuff that I used to miss, like the millions of garden eels that would pop out of the sand and the swim through and the beautiful Gorgonian fans. And I said, was that there? And their face just dropped and they went, I don't know if we were at the same site. But they'd already said how beautiful it was, and then I've rattled off all this extra stuff, and then they're like, oh, no, we didn't see any of that. It's like that realisation
that's what is said.
That's a great way to segue into how this impacts us all emotionally who are seeing these changes. And we as science nerds do tend to live a lot in our heads. We're always focusing on solutions so we can keep moving forward. But there is no escaping that reality that our reef has already changed and will probably never go quite back to how it was before. Definitely not in our lifetimes. Dr. Robbio, how does it make you feel to witness these changes on the reef?
I mean, generally, the coral reef I experience, like many of my colleagues and friends, is for the broader environment, not just coral reefs, right? It's not the driver for this. It's mostly the planetary systems we're losing. That affects me deeply. everybody has a different way to deal with this. So in our program, we have some specific, we call them climate cafes, where we have discussions to try and share how we work through this, because it's actually become a significant issue to manage in our program, because we are so at the coalface of dealing with modeling the future decay and decline of the reef. All of that is quite disturbing. And so we put some effort within the program. But everybody deals with these things in different ways. And I was asked at a conference, UN conference once, by a young scientist, very passionate, saying, how can you be optimistic? And my answer was, well, you know what? We'll be well gone as a society, potentially, and corals will still be there. They've been there for millions of years. They will adapt. They will do different things. Then they will go somewhere else or whatever. The point is not what we're losing. What we're losing is our human connection to that environment. Yeah. And if that's important to you, then we need to do something about it. Are corals going to disappear forever? Yeah. I don't think so. Life will find a way, but what I want people need to understand is that that's our human connection to the environment that is disappearing, and that's what affects me for my children and the future generations, is that connection, is getting more and more difficult to sustain.
Yeah, it's such an important part of mental health, is connection to the planet. Yeah. And to the environment.
There's also another connection to that too, is that I've noticed over the past few years at work, since we opened like 8 years ago, is that now I'm starting to hear a little bit more of the general public realising that now, where they're starting to feel like, if we lose parts of the reef and we lose that connection, and people are starting to become a little bit more emotional to it rather than just not wanting to hear about it. It's shifting a lot.
That's interesting. Yeah, Brett's job at the aquarium is a real good barometer of the public sentiment, because people from all over Australia and the world
millions
talk
of people
to him about how they're feeling about it all. And so to notice that you're noticing that grief coming out as people realise this isn't just an anomaly that's going to go away.
Yeah, and they're just sitting there. Like, I can have 110 people or so in one coral show or deep reef show, and I'll talk about the reef for 25 minutes, and sometimes you can hear a pin drop. Yeah. And that's all ages. That's, from 80-year-olds to teenagers to mums, dads, kids, whatever, and they're all just so engaged. And at the end, they're like, thank you so much, because we just needed to know the real story.
And the work you do is so important, because as scientists, we can do so much in terms of connecting with the people. And they're the people that drive societies to decide where the priorities are. Yeah. And so I think the work you do and the work you do on this podcast is just really, really important. We're not very good at democratizing science, but we're trying really hard. But I think that story is important, because it's just so difficult sometimes to have conversations with the people that hold the money, whether in corporate or whether in government, about how we prioritize things. And the population needs to be more aware, and the ocean is such a poor cousin to some of the land-based efforts we're doing in environmental management. We receive much less funding. I mean, the Great Barrier Reef is quite lucky in that sense, but overall, if you look globally, marine environments receive much less funding, and the gap in funding compared to what we need to achieve the sustainability goals internationally, it's so big.
It's quite ironic, because we're an ocean planet, isn't it?
Ocean planet, absolutely.
Yeah.
Well, we're doing our level best as what we can with our voluntary podcast and radio show to raise that little bit of awareness about the ocean, which is why we're so grateful to you, Dr. Robbio, for giving a bit of your time to help spread the message, get the message out there. I really resonated with what you said before, that if you take a really zoomed out view, like, lie under the night sky and look at the stars really far away and think, what happens on our planet actually is a tiny blip in the vastness of the universe, and that gives me a strange comfort. And the fact that things will recover themselves even when we are gone, but the thing to focus on is that that's going to take millions of years, and in the meantime we need to do what we can for the animals and people that are here right now that are going to suffer from environmental decline. What can listeners do if they want more information, or if they want to help or do something to help protect the Great Barrier Reef and marine life in general?
Yeah, look, I mean, clearly there are so many ways, and we're always keen for people to volunteer time and resources if they don't have time or both. So I think going to the various not-for-profits that work on the reef, not just ours, the Great Barrier Reef Foundation, but others, you can do that. There are so many opportunities to volunteer and connect. But also, I mean, the message I always give, even if you don't live near the ocean or near the reefs, if you don't have the time or resources, you can make differences in your lives. Through reducing emissions, obviously, reducing use of single plastics would be fantastic. But learn more about the ocean, share this knowledge with your children, and be an active citizen. What I mean by that is pay attention to the candidates in your area and what policies they stand for. Use your democratic power to vote for the people you think are best aligned to your values. And that's always the key message for me. That's where society needs to go, and that's where we can make a difference.
Great advice.
Excellent advice.
Excellent.
And by the way, Batman's behind-the-scene assistant is Alfred. So,
Alfred, is that what you looked up?
I'm Alfred. It's less glamorous, but I'll be Alfred. So
it's not he's not an Avenger, but he's part of the superhero network. So you're a superhero. Thank you, Dr. Cedric Robiot, Executive Director of the Reef Restoration and Adaptation Program. Thanks for all your amazing work, and thanks so much for joining us on Word on the Reef today.
And thank you for your time. It was great.
Yeah, thank you for all your hard work.
And thanks to you, all our listeners, for joining us on Word on the Reef today. This show is broadcast live from the Cairns FM studio, which is on the land of the Yidinji people. We'd like to extend our respect to elders, past and present. We'll be back next week with more marine science adventures, 10 a.m. every Friday on Cairns FM 89.1. And don't forget to follow us on Instagram at instagram.com/wordonthereefpodcast. That's all for this week. Best fishes.
Yay, safe diving.
And
Catch
see
you
you
next
next
week.
time.